we we will discuss famous photoelectric effect and the equation given by Einstein in order to explain the observed photoelectric effect. So we'll start with photoelectric effect and equation by Einstein. We all know what is photoelectric effect. In photoelectric effect, it is observed that when electromagnetic radiation, for example, light is radiated on metal surfaces, not all the metal surfaces, on some of the metal surfaces, electrons are ejected from the surface. So the I can define it as it is defined as ejection of electron from certain metal surfaces. For example, for example, potassium, sodium, etc. Electrons are electron. Sorry, when light, light or electromagnetic waves of some suitable frequency is irradiated. When electromagnetic waves of some certain suitable frequency is irradiated on metal surfaces, electrons are found to be ejected from the surface, and we call this effect is called photoelectric effect, and these ejected electrons are called photoelectrons. This was first observed by Hertz in maybe 1887, that time itself. But what happened is the then existing theories, obviously the classical physics, couldn't explain the observed experimental findings. Classical theory couldn't explain. So couldn't explain this. There are some certain experimental observations they couldn't properly explain by the existing classical theory. So we require a new theory, and which is put forward by Einstein in 1905, explained this photoelectric effect. For that, he introduced the concept that electromagnetic waves contains packets of energy. They are not the energy is not stored continuously in it. They contains packets of energy called quanta of energy, called quantas. Using this idea, he has explained the photoelectric effect by introducing an equation: h nu minus h nu 0 will be equal to kinetic energy max of electron. We know when electromagnetic radiations are irradiated on metal surfaces, for electrons are emitted. These emitted electrons are moving with a certain velocity. Obviously, they will have some kinetic energy. So he has given an expression for finding out the kinetic energy of these ejected electrons. This would be equal to h nu minus h nu. What is h nu? H nu is actually the frequency of nu is the frequency of electromagnetic incident electromagnetic wave. H is Planck's constant, so h nu stands for the energy of the electromagnetic wave. Wave quanta. Later on, this quanta is termed as photon, and we say h nu is the energy of the photon, and h nu is the actually the minimum energy required for the electron to come out of the metal surface. Okay, we require because electrons are bounded in the metal, and we need certain minimum energy for in order to get these electrons released from the binding of metal. So it is the minimum energy required for ejecting electron. So when an electromagnetic radiation of frequency nu incidence on it, it will have an energy h nu. It utilizes an amount of energy h nu 0 for releasing the electron from the metal surface. Then whatever remaining is taken as a kinetic energy of electrons. There will be many photoelectrons ejecting when radiations are irradiated on the metal surface. So this is the maximum possible value for the kinetic energy. We call this quantity h nu 0, usually we call this quantity as phi, which is defined as a work function of the metal, because the binding force with which the electron is uh, attached to the metal surface or metal is different for different metals. So we call it as work function, and which is different for different metals. We can make use of this equation to find out the energy of ejected photoelectrons, and which is well in agreement with the observed experimental result. And this is how Einstein explained photoelectric effect. Thank you.